The next topic we are going to start is symmetry. Okay. Before I will start the symmetry lesson, just recapitulate what you have studied in class 4. Class 4 we have studied about the line of symmetry. If you remember, line of symmetry is what is line of symmetry? A line when any plane figure is divided into equal part, then the line will come in between, that is called line of symmetry, and it will be exactly same. If I will give you an example, I will just example is, if you will take alphabet A, and if I will draw a line in between the alphabet A, see this side and this side are exactly same, okay? And if you will take the alphabet N, and if I will draw the line from here, it is not same. So the line which divide any plane figure, either alphabets or any plane figure, into two equal parts, then this line is called line of symmetry, and this process is called linear symmetry. Okay, this process is called linear symmetry, and the line which divide into the equal part is called line of symmetry. I will give you one more example with a, if you take a rectangle is having two line of symmetry. It will be folded like this also. A square is having 1, 2, 3 and 4 line of symmetry. So it has 2 line of symmetry, and square is having 4 line of symmetry. Okay, and if you take a isosceles triangle, again I am repeating what is isosceles. Isosceles means opposite sides are equal or two sides are equal. It has 1 line of symmetry, okay, and if you will take an equilateral triangle, all sides are equal, okay, then it has 3 line of symmetry. This is isosceles triangle and this is equilateral triangle. Equilateral triangle, all sides are equal. Isosceles, only 2 sides are equal. And scalene, no sides are equal. And scalene triangle is not having any line of symmetry. Clear to you? Now you must be thinking why square is having 4 line of symmetry and rectangle is having only 2 line of symmetry. I will explain you with the example. This is a square sheet of paper. Okay. How you will understand it is symmetrical? I am going to fold it. When we are going to fold this one, see this is exactly same. Then we are going to fold it from here. Overlap. Huh? Exactly same. Okay, it is not coming out from anywhere. Now we are folding it diagonally, exactly same, and then this is the fourth one. When I am going to fold it like this, this is also exactly same. Clear? So when we are going to fold any plane figure and it is just going to overlap each other, this is the best example for the line of symmetry. And this line which is coming here, you can see that this line, this is called line of symmetry. Okay, so I folded it like this: 1, this is 2, then this is 3, and this is 4. So the square is having 4 line of symmetry. Okay, now if I will take a rectangle, this is a rectangular sheet, and if I am going to fold it from here, it has 1 line of symmetry. Then I am going to fold it from here. It has second line of symmetry. This is the 2 line of symmetry, exactly same. But when we are going to fold it diagonally, it is not same. You can see this. It is coming out. It is not exactly overlapped to each other. Overlap means when we are putting this palm on this palm, exactly it will cover to this. This is called overlapping. Okay. So it is not going to overlap each other. It means it is not symmetrical through the diagonal. So that's why I said as rectangle is having only two lines of symmetry. Clear to you? Now I will show you the example of isosceles triangle. This is the isosceles triangle. These two sides are equal and this is the not equal. So when we will fold from here, it is exactly same. One line of symmetry. But when we will fold it from this way, if I will fold it from this way, it is not exactly same. See, it is coming out. When I will fold it from this way, this is also not same. It is also coming out. So that's why I said isosceles triangle is having only one line of symmetry. So if you are going to just guess it, isosceles is having two sides equal, one line of symmetry. Square is having four sides equal, it is having four line of symmetry. Rectangle is having only two opposite sides are equal, so that is having two line of symmetry. Clear? It has only one opposite sides equal, so one line of symmetry. Rectangle is having two opposite side equal, this one and this one, so it has two line of symmetry. And the square is having all lines are equal, all sides are equal, so it has four line. All sides means four sides, so that's why it is having four line of symmetry. So you can just conclude from here that a plane figure, if it is a plane figure of the all the sides are equal, pentagon five side, and if all five sides are equal, it has five line of symmetry. Hexagon, all six sides are equal, it is having six line of symmetry. Clear to you? Now next topic is plane of symmetry. What is plane of symmetry? When we are taking any solid shape, okay, and that solid shape is going to divide into two equal parts, a plane, because solid will be always divided by the plane. I will give you example by this. This is a solid shape and this is a plane, circle, and this is a sphere. So when this solid shape is going to divide by the two parts by a plane figure, okay, then this plane is dividing this solid into two equal parts, identical part. You can see this, na? These both are the same. So when this solid is divided by the plane, this is a plane figure, this is a solid shape. So when solid is divided by the plane into two equal parts, then they are called plane symmetry. And this plane is called plane of symmetry. Okay, so a sphere is having plane of symmetry, that is this is the circle. So when we will divide it, it is divided into two sections. So each section will make a circle. Okay, now we are moving to the solid, this cuboid. When we are taking this cuboid and we are going to divide into the plane figure from the between, best example you can take a knife and a piece of bread. Bread is in a cuboid form. When you will cut the bread through the knife, knife is a plane figure and bread is a cuboid solid shape. When you will cut it from here, you will get a section and it will be divided into two equal parts. Okay, so that plane which we are dividing this, it is also a rectangle because we have to divide it by the rectangle. So plane symmetry of this is by the rectangle. Okay, so what is plane of symmetry? A plane which divide a solid shape into two equal parts, then they are called a plane of symmetry. Now third symmetry is called rotational symmetry. As the name is only saying, we have to rotate the figure, either alphabet or any figure. So in this case, what we have to see, if I will take this is a square. Okay, I will start rotating. This is the first view. Just put this square as a starting point. Okay, I am taking it from here. This is the holding it from here. I will take a small one. I am holding it from here, and from here I have started rotating. I will put a mark here so that we will understand when it will reach to this point, it means it is coming to the original situation. This is the original position. It started rotating. First I rotated like this, 1, again it is in the same shape, then 2, then 3, then 4. Okay, so all the 4 turns, if its shape is like a square only, it is not going to change its shape. So it started from here, it is starting point, I rotate it, again it is a square, again I rotate it, square, again I rotated square, and it is rotated. So 4 times I rotated this picture, and all the 4 times I got the square only. So when we are rotating anything and we are getting the same image, okay, then the shape is called, it is having the rotational symmetry. And when it is had rotational symmetry, it has center of rotation also, and when it has center of rotation, it has order of rotation also. What is center of rotation? A point around which we have rotated. Okay, a point around which we are rotating, that is called center of rotation. How many times we have rotated, that is called order of rotation. So again I am repeating, this is the first one. Once, this is the original position. When I rotate it, again it is a square only, it is looking like your original position. So 1 rotation, 2, 3 and 4. So a square is having order 4 rotation. So it's having rotational symmetry of order 4. Okay, if I will take a rectangle, this is a rectangle, and again same thing, I am going to start from here. So when it will reach to this place, it means it comes to the original place. I started rotating. First I rotated like this. It is not in the original position. So this is the original position. Rotated once. Now rotated twice. Again it comes to the original position. So 1 time it comes to the original position. Then rotated like this. Again it rotated to the original position. So it is coming in the same shape 2 times. So it has rotational symmetry of order 2. Got it? Now, the third one I am taking with the example of this triangle. This triangle. Okay. When I am rotating first time, it is not in the same position, then not in the same position, then not in the same position. Now it is in the same position. So only 1 times it come in the same position. So it has rotational symmetry of order 1. Clear? Now, if I will take a circle, and I am rotating it, you can see as much I am rotating, it is always on the same position only. So a circle is having all points are at the equal distance, and it all, how many points are there? It is infinite. You cannot count the points. So a circle is having infinite plane rotational symmetry. A circle is having rotational symmetry of order infinite. Clear to you? Now if I will talk about the alphabets, if you are going to talk about the alphabet, just I will give you the example of alphabet. First I am taking the example of A. This is the first position. I rotated once 90 degree. Always we are rotating at 90 degree. So it is reaching to the this position. Again I rotated to the 90 degree. Then it is reaching to the this position. Again I rotated to the 90 degree. Then it is reaching to the this position, and again I rotated to the 90 degree, and it is reaching to the this position. So it means alphabet is having order 1. It is having rotational symmetry of order 1. Okay. If I will take O, same. Okay. I, so it has order 1 because only 1 times it's come in original position. So it has order 1. It came 2 times in their original position, 1 and 2. So it has order 2. I came 2 times, so it has order 2. Similarly, we can take the alphabet that is N. It is also of order 2. S, it is also of order 2. Okay, so rotational symmetry, a shape has rotation symmetry if it looks exactly like number of times when rotated around the center point by 360 degree. 360 degree means one complete rotation. The same thing as I explained you, this is the square. Okay, number of times it is rotated. This is the center point. I rotated 1, 2, 3 and 4. So number of times I rotated, that is 4, and all the 4 times it is looking exactly same. So what is this? A shape has rotational symmetry if it looks exactly like the original shape. This is the original shape. When I rotated 1 time, it is again in the same shape. Second time, same shape. Third and fourth. So 4 times it is looking exactly same. So it has order of symmetry of 4. Now, if I will take a rectangle, then it is the original position. I rotated 1 time. This is not the original shape. Then 1 time it is in the same position. 2 times. So it has order of symmetry of rotational symmetry of order 2. Now, all the figure, either you take the alphabet or any shape you can take, all the shapes are exactly coming on their own position after rotating it at 360 degree. Whatever the things you can take, they will be always coming in their origin. If I will take this pen also, it is the one original position. I rotated 1, 2, 3 and 4. So after completing one full rotation, it is coming in the same shape. It doesn't mean it has the rotational symmetry. Okay. Now, the second point is the point around which the figure is rotated is called the center of rotation. This is called the center of rotation. Then the number of times a shape will fit in onto itself on complete rotation is called the order of symmetry. Means how many times it fits. In square it fits 4 times, so rotational symmetry of order 4. Rectangle it fits 2 times, so rotational symmetry of order 2. So these all definition you write down in the classwork copy. Now we are moving to the example. This is an equilateral triangle. What is equilateral triangle? All 3 sides are equal. When I have rotated it to 120 degree, it is coming in their own position. Then again 120 degree, it is coming into its own position. So total is 120, 120, one more rotation will be there. And since place is not there, so I am not able to draw one more rotation. And that also of 120 degree. Okay. So 120, 120, 120, 360 degree. It means a complete rotation is 360 degree. From where this 120 came, equilateral triangle is having all 3 sides equal. It is a regular polygon. Polygon, you know, regular polygon means a polygon whose all sides are equal. So in case of regular polygon, when we divide 360 degree by the number of sides, then that will give you the angle of rotation. So this 120 degree is called angle of rotation. Means when we are rotating this shape at 120 degree, we are getting the same shape, exactly the same. Then again when we are rotating this, we are getting the same. So how many times it will be? 3 times. Okay. So 120 degrees, equilateral triangle is having the rotational symmetry of order 3. In case of a square, regular polygon, 4 sides are equal. It means on 360 divided by 4, we will get the 90 degree. So when we are rotating this square for the 90 degree, we are getting the exact figure. Okay. Same thing. Again one more rotation. Place is not there, so you have to do, but you have to draw 4 picture because order 4, here order 3, so you have to draw 3 picture. Now next is alphabet. If you will take the alphabet I, O, N, S, these alphabets are having the rotational symmetry. H also. Okay, so when we will take these alphabets, when we rotate exactly at 180 degree, we will get the same thing. Again we will rotate it at 180 degree, we will get the same thing. So 2 times it is coming in their own position, so it has order 2. So which alphabet is having the rotational symmetry? The alphabets are O, H, I, S and N. These alphabets are having the rotational symmetry. Now we are moving to the reflection symmetry. Reflection symmetry is just like a line of symmetry. when we will take, for example, I am taking this one, and this is a triangle. Okay. If I will flip this triangle from here to here, it is exactly overlap to each other. Huh? So it means this will be just, it fixed to this one, first one. So this line around which we are flipping to this one, and we are getting the, if you see this one and this one are the same. So this is called the mirror image of this one. You can say this is a mirror image of this one. And this line which divides it into two parts, this is a line of symmetry. I already explained you the linear symmetry. So this line and this is called reflection symmetry, because this is exactly overlapping to each other. Now it is just a mirror image of this one. Okay, some very nice example in the nature. If you will take a leaf is divided into the by the one middle part, and the both side of leaf are exactly same. Okay, if you will take the you might have seen the Taj Mahal. Taj Mahal is the best architectural example of the reflection symmetry or the linear symmetry. If you will see the Taj Mahal, many of you must have seen. If you have not seen, see the picture of the Taj Mahal. If you will draw the line of the a line from the top of the Taj Mahal to the base of the Taj Mahal, you can see that exactly both the sides are same. And if you see the reflection of Taj Mahal in the water is there is a pond in front of the Taj Mahal. If you see the reflection of that also, whatever is there upside, the same thing you will see down one. That is the reflection symmetry. So Taj Mahal, leaf, butterfly, and many more examples are there in the nature for the reflection symmetry or line of symmetry. Clear to you? I hope this topic is clear to you all. Now you have to do all the questions only in the book. And 9C, exercise 9C, question number 2. Exercise 9C, question number 2 you have to do in the copy. Then question number 3 also you have to do in the copy. And question number 4 you have to do only in the book. Okay. So question number 1 and 4 you have to do in the book. And question number 2 and 3 you have to do in the copy. So this is all about this chapter. Complete all the things whatever is given in the exercise, and at last same thing, chapter revision. You take it as a test, prepare the chapter, revise everything, learn the definition, and then solve this chapter revision in your revision copy or rough copy anywhere, and find out how much marks you are going to get. You should get always more than 80% marks in maths. Clear? All the best to you, all of you. Complete all the work, revise properly.